Ryan, do you want to kick us off?
Yeah, sure. So, quick introduction. My name's Ryan Baker. I manage the Northeast for EMC. So I have Maine, New Hampshire, Vermont, a little bit of 978, and then mid-market healthcare is how my team's laid out. I have 6 direct guys, 4 of which are here. So at some point, I'd love to get them all introduced. Based on the relevant territories. Today, I'm only going to speak for a second here. I just want to get more of an introduction side, and then if you can go to the slide here. I just want to touch briefly on one slide here for us. Based on the 35 minutes we're allotted, based on Joe's point, our portfolio is very big, right? There's a lot of different things to talk about. The world of hyper-converged and converged is a very hot topic for us as well. Again, I don't think we could cover that all today, so I wanted to note it. Maybe we can have a different conversation at a different time. But the focus today is on our growth areas, right? So the scale out, which is going to be the focus of today, both in the block and NAS arenas. The converged infrastructure, we're big on the cloud enablement right now, right? We're not fighting the cloud. 3 years ago, I'd say we probably battled the cloud. We saw it as taking away data center footprint, right? It's a very different landscape now. So we are very big on enabling our customers, enabling our partners to leverage the cloud and, within their 4 data center walls here. And then really data protection's at the core of everything we do, whether it's on our primary storage arrays, backup world, right, with data domain, things like that, flagship product for us. These are kind of the 4 big growth areas for EMC right now. There's a bunch of others, but again, I don't want to boil the ocean here for you guys. So that's really it. Again, we couldn't cover all this in depth today. Would love to come out and speak to you guys, get my reps involved, get our SCs involved, make it a good, worthwhile conversation. And from there, I want to introduce Andrew Fongemie. He's my field CTO, mapping to our entire area, actually. So Fonge lives up in New Hampshire, great guy, very knowledgeable, came from our internal IT team. So, Fonge, floor is yours.
Yeah, thanks. As you can tell, my nickname is the Fonge, so I've had that nickname all my life. So quick intro, I've been with EMC for roughly 15 years. My first 10 years with EMC was within our own data centers, and obviously EMC, we're quite a large company, and we have quite a few data centers. My time there was spent as a storage architect, so I know what it's like, to manage infrastructure and particularly manage our own products. So I've got a good background as far as that goes. I've been with the sales organization for the last 5 years, and as field CTO, if I can manage my demo, as field CTO, my job is to kind of look at what's going on with trends and things of that nature, and stay on top of where the market is going and make sure that I'm talking about our leading products. So right now we're going to be going over Extreme IO. Let me get the slideshow from current slide. There we go. So we're covering a couple scale-out platforms. We're covering Extreme IO for scale-out block. Extreme IO is not our only scale-out block platform. We've got VMAX. VMAX's been around, Symmetrix family, right? It's been around for a very long time. And now we even have something called Scale IO, which is scale-out and commodity hardware. By far, probably the product that resonates most with our customers is Extreme IO. It's an all-flash array. All flash arrays are hot at the moment for many reasons, and Extreme IO is our offering in that space. As far as product revenue, Tom, you're our sales specialist, so we've hit $1 billion within a very short period of time, correct?
588 days.
Yeah, so we've never had a product that was that successful and hit that kind of revenue within a short period of time. And for me, it's my favorite product, and the reason why it's my favorite product is because at the end of the day, I had a career in IT managing spinning disks. And spinning disks are not great at performance, they're not great at capacity, and when you have requirements that need to kind of meet either of those or both, there's a lot of work in storage architecture that you need to do up front to kind of do what you need to do in terms of deploying applications in a way they're going to be successful and they get the response times they need, they get the performance they need, right, the capacity they need. And it's a lot of work, right? There's a lot of management overhead, and there's a great skill set involved in doing that sort of thing. And on top of that, if you need a lot of performance with spinning disk, you need a lot of drives. If you need a lot of capacity with spinning disk, you need a lot of drives. And that drives data center costs, right? Power, cooling, things of that nature. So I left IT in 2010. Before I left IT, we started putting flash drives in our storage arrays, which was awesome. Great thing, right? Love the fact that I can now start putting flash in my technology. The problem back then, though, is the drives really weren't that large. And at the same time, they were pretty expensive. So I had to kind of surgically pick within my environment where I'm going to leverage flash. And obviously, like the mission critical apps, maybe I'd take a component of a database like indexes or temp or something of that nature and kind of surgically place those components of an application on flash. All right, so there's still a lot of management, there's still a lot of forethought and things of that nature. Well, the world is changing, right? So the economics of flash have greatly reduced, right? So flash is now actually accessible to basically everyone, right? Even from the small SMB customer all the way up through the enterprise, you can now acquire flash drives. And the great thing about flash drives is the quality of the drives have increased greatly as well. In the early days, they kind of were a little inconsistent. You know, they're doing things like their own internal garbage collection. They had issues with that, right? So a lot of, let's say, kind of all flash array makers, not us, but some others have decided, you know what, we're going to remove that function from the drive itself and we'll do it at our level. We'll do kind of like system level garbage collection and things of that nature. So there was kind of issues with the flash drives when they first started, right? Those issues obviously have gone away over the last few years, right? And then, you know, given the size that the drives have increased in capacity, they've come down in cost, people are now have the ability to look at their environment and move to an all-flash data center, right?
Real quick.
Yeah, go ahead.
So Jay Carter came down, he's from Memic up in Portland. I brought Jay down because of really that slide, right? He's moving toward the all-flash data center for really pretty much every block workload, right? So again, I wanted Jay to, you can say something now if you want, but again, Jay will be around if you want to ask him questions, but real-world customers are moving to, you know, the all-flash data centers, you know, because the inherent capabilities that you do, pretty much any block workload can go on it, and, you know, so again, Jay Carter from Memic, please feel free to pick his brain a little bit afterward. Sorry, fun.
Yeah, no problem. And basically, this is a TCO summary slide for one of our accounts in the area. This is a very common slide. Oftentimes, I'm walking into an account, customer has very large storage arrays consuming multiple tiles. They drive a lot of I/O, a lot of capacity, and they'll be able to walk in there and say, you know what, we can do better, right? With an all-flash array, we can reduce, let's say, your time to provisioning, right? We can reduce that significantly by making your life a lot easier because you no longer have to set up pools and RAID groups and things of that nature, complex layouts. All that goes away. We can reduce power and cooling costs. We can reduce management overhead. We can increase your application performance. Probably one of my favorite deals to go down is an all-flash array because once that environment gets implemented, it's the same story over and over again. You walk in there after they've actually migrated onto it and you hear, hey, you know, we had this report, it used to take us 5-6 hours. It was really problematic. We had this workload that took forever. We moved in with an all-flash array. That report now completes within a few minutes. My applications are performing a lot better. Data center folks are happy because we've given back dozens and dozens of floor tile. The cost of power and cooling is reduced significantly. So there's always a great positive feedback from the customer base once we go in this direction. Any questions on that? So when we started kind of getting into the all-flash array space, initially we were kind of targeting point solutions like VDI was a huge one, right? Everyone wanted to do VDI, all-flash array. VDI, there's a great deduplication story there, and there's also a pretty heavy workload that needs to be satisfied. So, you know, like EMC, you know, we started targeting VDI, and then as our offerings started getting more advanced in terms of data services, we could do deduplication, we added compression, we started adding snapshots. It allowed us to take on additional workloads, and probably the biggest workload, because we were able to do compression on the platform, is databases. Now I talk to database customers more than anyone else. So everyone's taking their databases and moving them to all flash. And then actually this year, we're starting to see a lot of great things like, for example, in the NoSQL space. You know, NoSQL, a benefit and a best practice for NoSQL is leverage flash where you can. NoSQL dedupes fairly well also. So a lot of our customers that are looking at deploying NoSQL, like Mongo or Cassandra, are also leveraging Extreme IO as back-ending that type of platform. And then like the big data analytics space, you see here, we've got Splunk and so on. But the point of this is we no longer look at these solutions as point solutions for particular applications. We actually look at the entire data center, and it's now more of a consolidation play. All these workloads, block workloads, can come onto this platform. Does that make sense to everyone? Okay. Yeah, go ahead.
Previous slide, you had a before 500 gigs after 80 terabytes, 500 terabytes to 80.
Yeah. You know, oftentimes this happens a lot. Oftentimes when you're deploying for, let's say, this Oracle database, it drives a ton of I/O. It's not that big, so you end up short-stroking spindles to get at the I/O. So you have all this kind of captured, locked-in capacity that's been provisioned to an application, right? Because we needed the spindles to satisfy the application's I/O. So what we do is we do our assessments. We track what are you using in terms of workload, what are you using in terms of capacity, and oftentimes we're able to actually service back to the environment, a smaller footprint in terms of usable as well as kind of the workload what we're going to drive, right?
So you go like from a RAID 10 to a RAID 5?
Yeah, I'll get into. We don't do RAID.
Well, but
Yeah.
that would be the analogy.
Yeah, exactly. Or maybe this database. You're right. The data was, maybe I did a RAID 10 for the logs and RAID 5 for the database, but I needed 20 spindles for the database. But that database, really for physical capacity, maybe only needed 5. But because of the I/O, here's 20. And by the way, no one else can have that 20. So I've got all this captive storage here that's just satisfying I/O requirements. Happens all the time with spinning disks, right? And that's part of what a storage admin's job is try to figure all that stuff out and be as efficient as possible. Service the workload as best they can, but also you got to meet the capacity requirements, right? And then, like in 2010, when I would talk to a DBA, you guys probably heard of these numbers as well, when we get into sort of response time type questions, hey, it's log, 10 milliseconds, we'll shoot for that, right? It's a data line, we'll shoot for 20, right? Those are typically kind of the best practice, general numbers that get thrown out. Those numbers are garbage now. DBAs, they want millisecond and below, right? No one wants 10 millisecond log, 20 millisecond data lines. Forget that, right? But that's the way it used to be. Now, when we go all flash, right, customers see latencies in terms of, like, for example, Extreme I/O, millisecond and below. Does that answer your question? I think there was, okay. So let's continue on. Let's come back here.
And Fonge, for that customer, that 60 usable with data reduction, we gave them an effective 200 terabytes.
Yeah, we'll get into data service because thin, right? Often, so we can do thin as well. Oftentimes, the traditional storage arrays, there's a penalty cost to thin, right? So oftentimes, environments are thickly provisioned. Here, we can leverage thin, right, with no performance penalty for it. And then, as far as what you should expect from an all-flash array, I/O is a given, right? Everyone's going to give you I/O with flash, okay? What you really should be thinking about is consistency and low latency. Those are the values you should track. I/O, everyone's going to give you the I/O. It's consistent, low latency. And to be honest with you, to get there, right, there has to be a lot of thought in terms of the architecture. So architecture matters, right? So what's the value prop of Extreme I/O? How is its architecture different from other flash players? We'll get to this slide right here, and I'll just build it out. It's going to build for me. So we don't do, in the early days, flash drives were not good at doing their own garbage collection, so that task was offloaded to, a lot of companies kind of offloaded that to the storage controllers and wrote their own garbage collection algorithms. And the way they accomplished that is through a post process, a scheduled post process. We don't do any of that. When we acquired Extreme I/O, they were already working with an Israeli SSD vendor who kind of figured out the garbage collection kind of problem on flash drives, and they created a garbage collection algorithm on their drives that was consistent, no hiccups, no issues. So we allow the garbage collection for us to actually run on the drive itself. So we don't do any controller level post-process garbage collection. Because honestly, post-process gives you erratic performance. Again, if you're looking for low latency and you've got these controllers who should be servicing front-end I/O doing post-process type workloads, well, they're going to get busy, right? And they're going to start, there's going to be some contention there. So we don't do that. We also don't do legacy RAID. And I'll show you in the demo, when we provision a Stream I/O environment, a brick into your environment, you just see a pool of flash, and you provision from that pool. You don't have to worry about RAID 10, RAID 5, RAID 6, none of that, right? Because we do actually what we call XDP, it's in-memory RAID. If you want to put a number to it, think of it as like 23 plus 2, right? Because each brick, and I'll show you this in a few moments, has 25 drives. The way we protect the data is actually doing a 23 plus 2 algorithm. And then in terms of architecture, we're a dual controller, active, right? It's not active, passive. So some of the systems out there, they'll have dual controller, but the LUNs I/O must come through one controller. The other guy's just sort of hanging out, waiting for that controller to fail, and if it fails, they'll step in and do the work. For us, we don't do that. All of our active systems, all of our scale-out systems are always active controllers. So here's an example I can start off with one Extreme IO, we'll call it a brick. It's dual controller. And if I want to add capacity into the environment, I have the ability now to scale out up to 8 bricks. Since each brick has 2 controllers, it's 16 controllers, right? If you see here the marketing number in the below hand, right, 150K IOPS per brick, it's kind of a hero number. You're going to get over 100,000 IOPS, but if you look to us and you want us to size a solution for you, a good engineer is going to ask you about the workload. IO sizes, IO types, it's going to kind of drive what that number is really going to be, but it's going to be in the 100K range. So if I have a cluster and each brick is doing 100,000 IOPS comfortably, and I have 8 bricks in that cluster, that's a pretty performant pile of storage, driving a lot of IO at low latency in a very small form factor. And that's how we're able to consolidate data centers, right? So here's the building block. Dual controller, 25 drives within the disk shelf. We've got redundant battery backups. So EMC, obviously, part of our claim to fame is ultra high resiliency and redundancy. So all of our solutions are always going to have, N+1 in terms of data protection and redundancy. So dual controllers. We can start off with a single brick, right? So the single brick has front end connectivities. It could be fiber channel, it could be iSCSI. If we add bricks into the cluster, those bricks talk via InfiniBand. And as I add bricks into the cluster, my data spreads across the bricks within the cluster. So it's not a concatenation. It's we add a brick, we started off, let's say, with 1 brick, we add another brick, we've got the double the capacity, and our data automatically rebalances now across the 2. So you get the benefit of the performance of both bricks. So let's get into some of the data services. Always on thin provisioning, right? So your volumes are going to be thinly provisioned. Inline deduplication, it's not a post-process job. Inline compression, it's not a post-process job. Extreme data protection, that is that kind of our version of RAID, but it's not legacy storage array RAID, it's at software level. Inline data at rest encryption, a lot of customers like that. They like the fact that we can encrypt drives, right? So by default, the Extreme IO brick will be encrypted. And then agile writable snapshots. So we have the ability to do snapshotting, read-only snapshots, read-write snapshots. We can do a restore from a snapshot to a production line. We can refresh a snapshot against the production line again. So in terms of think of what you can do with the snapshots, we can do it. We can do snaps to snaps and all this good stuff. And why that's important is in database environments, databases always drive replicas. In the old days, if I had a production database and I needed to create a replica of it, I probably wouldn't leverage a snapshot, because a snapshot in a traditional storage array, here's my production LUNs, it's on these spindles, I take a snapshot, that snapshot is pointer back to those spindles, so my workload is actually, got my host mounting my snap, I got my production host, they're hitting the same spindles, right, with a snap. That's the reason a lot of people use clones. Full copy clone, get it off different spindles, now the workload's segregated. You don't have to do that with Extreme IO, because the way we do snapshotting and the fact that we can do an amazing amount of IO, you no longer have to worry about, yeah, here's my production database, take as many snaps as you want, and I'm not worried about whatever the use case of the snap, backup, analytics, test dev, I'm not worried about that stepping on my production workload. And because we're doing deduplication, every snap is free, right? So I can offer multiple snapshots, give the same performance SLA as production to many environments. And what we're seeing is oftentimes customers will leverage Extreme IO and their development activity starts to increase and their development windows start to shorten because they now have the ability to work on multiple copies, multiple streams, and it allows them the ability to be more agile. Does that make sense? Okay. Here's an example of a customer, and I know in the interest of time I want to kind of roll through this. So here's an example of a customer that had 50 copies of their database. And what we did is by leveraging Extreme IO, they were able to, the 50 copies consumed 125 terabytes, they moved to Extreme IO. After moving to Extreme IO, they were able to get like a 31 to 1 reduction ratio, and instead of consuming 125 terabytes, they were now consuming 4 terabytes. Think of that. Think of trying to offer your developers all those snaps, right? It's hard to do in traditional storage arrays. It's really hard to do because it ties up capacity, it ties up performance, and then creating those environments is not easy to do in terms of a technical standpoint. So this is a huge use case where we're seeing a lot of database folks wanting to talk to us about this technology. Another great selling point for Extreme I/O, and I'll just get to the 7-year kind of window
I
here.
can cover that
Go
quickly
ahead.
for you. So I've been in EMC 12 years. Anyone who's dealt with EMC or any really big storage provider knows every 3 or 4 years we're going to knock on your door and try to tech refresh you, right? Because the maintenance skyrockets. Extreme I/O, that all goes away, right? And I think we've acknowledged the fact that the reliability of these enterprise class flash drives, they just don't fail much. There's no moving parts in these flash arrays. So what EMC is doing is, depending on how you negotiate your deal, it's maintenance locked in out to 7 years. So 3 years out of the box, just like most stuff, but now years 4 through 7, it's 11% of your acquisition cost, right? So that's 11% of net, not list, right? So rough and tough math, you buy a $200,000 brick, $150,000 brick, it's 11% of that price. And that's through year 7. So that's huge. Customers are really gravitating to that. Great. That's really honestly what customers are talking about the most, is the fact that it's maintenance lock, it's protection, and these assets are just living longer because there's really no moving components in them anymore. So
Yeah, and I can't think of another product that I would tell a customer, buy it now and be committed to that platform for 7 years, especially if there's spinning drives in it. And the reason why maintenance goes up on platforms that have spinning drives is spinning drives, as they get older, they die. So if we've got a drive in a system that's 5, 6 years old, there's a likelihood that that drive is going to die. So we're going to be servicing that platform more often, which means higher cost to us. So obviously, customers that have platforms with spinning drives, that's why maintenance goes up over time. This shows you kind of the architecture of Extreme I/O, where we drop in a drive here, and that thing's going to have a 7-year life cycle on it, and we're not worried about it. That's why we can guarantee year 1 that cost of maintenance is going to be the same as year 7. And a lot of customers like that as well.
to give you an idea real quick on the point, I heard this fact yesterday. We've sold over 6,000 physical bricks to over 2,700 end users, so they bought multiple bricks. Out of that many drives that have shipped, we've about 160 drive failures in these. And I think over half of those were DOA. So to give you an idea of the reliability of these drives, it's nothing like we've ever seen in spinning media.
All right, the demo. So I apologize, kind of the projectors cut my interface down here, so I'll have to slide over a little bit. But when I log into Extreme I/O, this is a very easy to use platform. Okay, so the great news is if you have storage admins stuck doing a lot of storage kind of tweaking and all that and configuring and spending a lot of time there, they drop in Extreme I/O and they can do other things, more value add type activity back to the business versus fighting with storage layouts and so on. So I log into the interface and I can see, for example, my efficiency ratios. For example, this platform I'm showing 14:1, let's say it. And well, how am I getting that? Well, I'm getting deduplication, here's the value. I'm getting compression, right? And then thin provisioning as well. And these values all make up what my total efficiency is going to be. Now, if I see what I've provisioned out to the environment, I've provisioned out about 50 terabytes worth of LUNs. On the Extreme I/O, I've only consumed about 3.4 terabytes of space on this here is a 15 terabyte brick. So I can provision out a lot of capacity in a very small footprint, right? So let's get to the main point, right? As far as performance, that's great. We can drive a lot of I/O, we can drive a lot of bandwidth, right? That's fine. But the more important thing is latency. Oftentimes when I look at performance charts with Extreme I/O, the average kind of hangs around 1 millisecond below 1 millisecond. So think of providing that kind of response times back to your applications. It's huge. When I have flash meetings with customers, it's great to have a storage admin sitting over here and the DBA sitting over there, and they're both on the same page and they're both all in, because there's a lot of value that gets added here with low latency. All right, okay, so in the interest of time, let's configure some storage here. So if I want to create a volume on Extreme I/O, there's no pools, there's no RAID groups. It's just a matter of clicking Create Volume. I'll give it a name, call this guy Testlun. I tell it its size. We'll go 1 gig here. And I'll say Next. And I can tag, so Extreme I/O has this concept of tagging, Why do I want tagging? Maybe this is an Oracle prod, maybe it's Oracle Dev. I could have nested tags. The reason why we have tags is to enable reporting. So you could create a report on, show me all my production volumes, show me all my development environments, show me all my Oracle, whether it's prod or dev, and you can search on particular tags to provide that data back. So that's the value of taggings. So I've created my LUN, test LUN, and now I want to map it. So it's as simple as my screen is cut off right here. So let me show you that again. So here's my LUN I created. Okay, I just come over here and create modified mapping. Here's the host that I want to see that LUN. I say next, finish. It's as simple as that. If I want to create a snapshot, it's as simple as create snapshot. I won't give it a name. I can if I want. I can even give this snapshot a tag. And if I want to do things as, here's my test line, here's a snapshot. If I want to do snaps on snaps, I can do that as well. Believe it or not, a lot of developers like that. They like the ability to say, hey, I've kind of created this code. I want to stay here, but I want to take it to another path too. And if I like where I'm going here, I can delete this point and then continue on. Or if what I did here kind of doesn't work, I want to be able to revert back. So snaps to snaps offers that value. And by the way, I can just keep creating snaps all day long. I can create like 256 snaps, and I can delete snaps out of any order. I don't have, one snap is not reliant upon the other snap survival. In fact, my snaps aren't even reliant upon my source LUN survival, because all this is metadata and memory pointers. All right. And obviously, you know, we've got, let's see here, we've got reporting as far as built into the system. You can create custom reports as well as we've got pre-canned reports, but obviously you want to have the ability to look into the system to see what's going on. With the latest version of code, you can now hold 2 years worth of data on the system. So you can really go back in time if you want without having to kind of create this other reporting environment to hold historical data. 2 years is a long ways to go back if you wanted to do that. Any questions on the demo? I want to make sure I get to the other topic as well as if you guys have questions. Does it seem interesting? Have you guys heard of Extreme.io before? Something? Anyone have Extreme.io? Obviously.
Yeah, I was going to say, hey everybody, my name is Mike McMillan. I'm the account manager for Maine. Just want to give Jay the opportunity for like a minute or two, if that's all right. So Memic out of Portland probably has the biggest Extreme.io footprint in Maine. I mean, larger than a lot of the enterprise accounts, and they 20, 30 terabyte shop, insurance company, has a different vision for their infrastructure. So I wanted Jay to have the opportunity to kind of walk through for a minute or two, a little bit about why they chose it, the benefits they've seen, and kind of touch on that. Because I know what you're thinking. I mean, if EMC's coming in here, you guys, if you've had experience before, good or bad, share that with us at the trade show. But also, this isn't for, you know, the top Fortune 200 companies. This is a solution, both of these solutions that can work, and from a price standpoint and also from a benefit standpoint, to any type of customer, both small, medium, and large. And I think Memic is a good kind of representation of that. So, I'm going to touch on it.
So right now we fit exactly in that small, medium business space. And as Ryan said, we were at the technology refresh stage. And one of the driving factors that we really wanted to accomplish with our next stand was going to be encryption of data at rest. We have a lot of PII data, as you can imagine, and we really wanted to address that with hardware-based encryption, not software-based encryption. When we started looking at Extreme.io, we thought it was probably, you know, next generation for us, absolutely not something we could approach now. But when I started crunching the numbers and I started looking at an Extreme Promise, it had about $45,000 of actual revenue value for us over those 7 years for the maintenance cycle. And then when we looked at where we wanted to go in the future, we want to implement network virtualization in 2016. We want to implement VDI in 2017. I needed something that was fast. We want to build out an enterprise cluster and move our data warehouse from an archaic system into a SQL enterprise. And so when I started looking at all these high performance things that we were going to be asked to do, and stand up SharePoint and move from notes to Exchange and a lot of other tasks that were going to be very resource bound and very timely to have very quick searches on disk. We looked at Extreme IO and it made a hell of a lot of sense for us. And I realized that buying it now with the incentives that we could get because it's an emerging technology, it would probably take 3 to 5 years in the product life cycle for the volume of manufacture to come down to a point where we could afford it the way we could right now. It was a bit of a reach up for us, but when we talked with the management group and we explained to them what the benefits were in the long term, they were very, very willing to spend the additional money now to get the value and to have that 7-year maintenance cycle that we didn't have to worry about. Our initial experience with the first brick has been so well that we did an out-of-budget infrastructure increase, and we included another brick in that, and we'll be putting that in the next 4 weeks.
Whatever you want.
Tomorrow.
Done.
Yeah. So, you know, from a performance perspective, from a future load perspective, from a data center reimagining, it was a solution that made a lot of sense for us. And the performance has been spectacular. The reduction in management overhead has been very noteworthy from our system support group that managed this. And it's just been a pleasant experience all the way around. I will say EMC is probably one of the very few vendors that I've experienced where if you have any type of a problem, and we had some initially, not with the disk itself, but with the purchase process and the VAR we went through, which wasn't access, so it's nothing about access. They jumped in, said, we own this, we'll get resolution to this. I've never experienced that before. Usually it's like, hey, you know, we sold it to you, you got to work it out with whoever on the other end. EMC's been a fantastic partner. They've been there with us if we've ever had a problem. You know, they've brought the resources in, they've gotten us the education, they've exposed us to their new technology. A lot of what we're doing future-facing is going to be based on a lot of what EMC's technology is both now and what it's emerging to in the future with B-Block and some other things. So it's been a great partnership and it's a phenomenal product, and we really look forward to getting more performance out of it.
Thank you very much, Jim. Appreciate it.
All right, so Extreme IO was scale out for block. Isilon is scale out for unstructured data. And I'll walk you through what unstructured data is in a moment.
Just to keep you honest, we got about 12 minutes. I don't want to.
Easy, not a problem. So real quick, IDC slide, obviously the amount of growth for unstructured data, you know, they're saying around 71 exabytes in 2015, and that's obviously going to almost double by 2017. So EMC sees this as well, and kind of our premier product to deal with unstructured data is Isilon. So how do we define unstructured data? It's more than just file shares, right? So file shares make up a huge component of that, but we see a lot of things around, let's say, VMware with NFS. We see a lot of Hadoop type customers. Anyone here doing Hadoop? Any MapReduce type customers? All right. So good news is, so there's the thought is Hadoop is going to die in a couple years, and probably will, and be replaced by Spark. Spark can read from HDFS. Isilon has the ability to do native HDFS support. So our story here is going to continue on just as strong, you know, regardless whatever happens with Hadoop and how it gets replaced with Spark. We see a lot of folks doing a lot of analytics against log data, Splunk. We partner with Splunk all the time. We've got a great reference architecture with both Extreme IO and Splunk. Any Splunk customers? There's got to be a Splunk. Oh, finally. Thank you. Yes. Yes. By the way, I'm not as strong in this product, so this is the one, if you guys, anyone out there wants to play Stump the Chump, this is the one to go after.
I got your back.
All right.
By way of intro, real quick, I should have. Kevin Powers runs the Isilon business unit for the entire Northeast. So if something comes out of this, you need more. You know, Kevin's here.
Okay, this one quick, I'll back up. So scale out in terms of the ability to add, this is kind of like the commodity hardware story where you add nodes and that those nodes participate in a common pool, and as I add, if I need to increase capacity, performance, I add more nodes, right? So Isilon is kind of the same story. So here's my Isilon nodes, I have a 4-node cluster, right? And if I need to add more capacity or performance into that cluster, I can add a node. It's online, takes like 60 seconds. Customers love that, right? The other thing they love is I can have up to a 50 petabyte file system. So think of your environments right now, if you're challenged with maybe dealing with 16 terabyte file system limits, right? All that kind of goes away with an Isilon. One file system that can scale up to 50 petabytes if need be. So great scale. As we add capacity in Isilon, obviously is hugely important. We need to rebalance, right? So let's say here I've filled up my cluster, added another node. That node joins the pool, takes like 60 seconds, and then data starts to balance across. So it's not a concatenation, just like Extreme I/O. And obviously that gives us a good, gives us the ability to provide consistent performance, right? And gives you a nice balanced environment with no hotspots. So obviously hugely important. So that little graphic you saw with Isilon kind of balancing out, Extreme I/O does the same thing. Okay, we have got multiple families within the Isilon. So we have high performance nodes where it's all about performance and little capacity to just very dense nodes where it's all about low cost per gig. Okay, so if I build a cluster, if I start with, say, a particular node type, I have the ability to scale out these nodes. In this case, maybe I'm going with a high performance node, and I can scale both performance and capacity linearly. However, that tends not to happen with a lot of our customers. They like to mix node types within clusters. So what are our node types? We've got the S series, which is our high performance nodes. We've got our X series, which is kind of like, yeah, we're pretty good with performance, we're pretty good with capacity. We're not awesome with either, but we're kind of right there, that middle ground node. We've got the NL series, which is more about dense capacity with a little bit of performance. And then we've got the HD series, which is all about cheap, deep, dense storage. The good news is we've got a technology within Isilon called Smart Pools. Let's say you have a file system, you land your data in the file system, and let's say you have data in that file system that doesn't get touched over time. We have the ability to auto-tier that data down into the right node type based upon policy. So auto-tiering for file. And then on top of that, so Isilon Smart Pools is about auto-tiering within a cluster to different node types for the appropriate use case, or just maybe the data is old and it hasn't been touched in a while, so we want to tier that down to make room on a higher performing node for more space. We also have the ability to do what we call cloud pools. This allows us to actually archive off to the cloud. So we basically need an object target. So Smart Pools, I'm tiering within the array. If I really want to archive old data out, I can actually archive it off to a cloud target as well. So tiering within the array, tiering to a cloud target. As far as the value Isilon provides back to our customers, obviously it's a very powerful platform, has a lot of flexibility, a lot of capabilities, the snapshotting, the auto-tiering, all sorts of great things that can come along with Isilon, but it's super easy to use, right? So customers that buy Isilon, they're no longer managing disparate islands of NAS storage. They have this big one consolidated file pool that's super easy for an admin to manage. And again, we can have a file system scale up to 50 petabytes. So it's very simple for them to manage the environment.
Yeah, the use cases here, again, just to chime in real quick, what I'm seeing is I have a lot of healthcare accounts, I have a lot of higher education, a lot of school districts, a lot of state agencies, right? So where customers seeing a lot of value here is, multiple use cases where the physical security team at one of my schools manages their surveillance. They got a little silo of whatever came with that surveillance package they bought. Customers are now looking to deploy Isilon, either mid or cheap and deep tier, just to get it all centralized, right? So again, getting away from the islands of disk. Healthcare is another great example. Yeah. So there's a million different use cases for this, and those are just some of the use cases I'm seeing most frequently, right? Is the unstructured stuff's just blowing up. We don't want to manage a bunch of different silos of this. It's just getting too big, it's too tough to manage, can't back it up, all the same problems, I'm sure.
Yeah, oftentimes campaigns will really, oftentimes it's easy to start with a file share conversation, right? Great, what do you have for file share requirements? Obviously, we can easily handle that, but then we expand the use case conversations to try to include these workloads as well.
Yeah, and I would just kind of jump in quickly is customers have moved forward with more, the flash environments for block and for those type of workloads. Very rarely does somebody say, hey, I need my video surveillance to be on an all flash array, right? So we're meeting the performance requirements of those other, file structured workloads with Isilon. And it gives them a specialized kind of option so that they can have all flash for the block-oriented applications. And then for the unstructured stuff, typically if you have a few of these applications with some high growth numbers, Isilon becomes a cost advantage for you.
Yeah, some companies in the area that leverage Isilon. There's some logos up there that are fairly well known, obviously. I think that's it.